Okay, so we are just going over the last page of examples. Shouldn't be terrible, and hopefully you tried it before watching this part of the video. Basically, when we integrated a constant, I wanted to draw back to attention that if you see a constant, when you integrate, you're adding the variable of integration to it. So dx, the variable of integration is x, so this just becomes 1/2 x. And the dx is a reminder that it's plus c because they have no bounds on there. So that is going to be the integration for part A. For part B, again, the variable of integration is x. Now they don't even have to have a 1 there. They could have just given you the integral sign with dx, and you would then know that there is a 1 there. Okay, this is just going to become that coefficient stays. You add the variable of integration, which is x, and that dx turns into c. Okay, here, when I integrate this one's a little bit different because the variable of integration is now t. So your constant's -5, you just add that t to it, and then it's plus c. Okay, so that hopefully wasn't so terrible for you guys, and you were able to do this one. Here too, we said it in the in the directions. Rewrite before integrating. There's no such thing as quotient rule, chain rule, product rule. So it's either basic integration, adding that 1 to the exponent and dividing by that new exponent, or something that's called use substitution, which will eventually, you'll see it's very obvious when you would have to use this. So this, I can't integrate when the variable is in the denominator. I need to rewrite this. At this point, you should know that if to bring this up, that 1 stays there, it's x to the -3 dx. So now I just rewrote it. Now the integrand is in the correct form for me to integrate. I'm going to add 1 to it. Well, then that becomes x to the -2. And then you're going to divide by that new exponent of -2. This dx turns into plus c, so this is just now -1/2, right, because it's a -1/2. Now I'm going to put this back down here, x squared plus c. That would be my answer there. Okay, for this one, you need to rewrite this. So the integral, the square root of x is the same thing as x to the 1/2 dx. Now that you rewrote it and the integrand is in the correct form, you're going to add a whole. Well, when I add a whole, I need to add it in the form of 2 over 2. So this now becomes x to the 3/2. Now this is really, really important because we're dealing with fractions. Whenever you divide by a fraction, it's the same exact thing as multiplying by the reciprocal. So some of you are going to want to do this. Divide by the 3/2. Well, you can, but what you really should be doing is saying, listen, this is my new exponent. I'm going to multiply by the reciprocal because it's fraction, so it's 2/3. Which if you went ahead and said 1 divided by 3/2, well, that's going to become 2/3. And the dx is plus c. Really, 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 really important is that when you divide by a fraction, you're multiplying by a reciprocal. Okay, so that's something that you really need to walk away from today's lesson knowing pretty confidently. Okay, and then the last piece. It was integrating polynomial functions. When you integrate polynomial function, just means many terms. This was the rule that you could break this up to 2. I would never suggest doing that, but that's what you're doing. You're integrating each piece. So instead of doing this, which is totally not necessary, that's the sum rule, I'm just going to integrate each term. There's no exponent on this parentheses, so you don't need it there. I just put that there purposely because sometimes just having that present confuses kids. So the exponent here is 1. That's just going to now become x squared because you're adding 1 to that exponent. So it becomes x squared, divide by that new exponent. This is a constant. Well, the variable of integration is x, so that just becomes 2x. And what does that dx turn into? Plus c. So I just integrated a. So b, same idea. You're adding a whole. That now becomes 3x to the 5th. Divide by that new exponent, 5. minus, you're adding a whole, so that becomes x to the third, divide by 3. Plus this is 1, so you're adding a whole, it's x over 2 x squared divided by 2. The dx is my clue to don't forget about that plus c. So that's your answer. You could also rewrite this as 3/5 x to the 5th minus 5/3 x cubed plus 1/2 x squared plus c. That is something you want to take into consideration, that you know that this is equivalent. All right, so hopefully it wasn't too painful and you got your first lesson of integration. Try the homework. It'll just be a couple of practice problems, and we'll meet again to continue with a little bit with what we'll learn particular solutions.